Hello everyone, this is Prasan Shrestha and I'm a student in Concordia University, Chicago. And this is an assignment which is Introduction to Software Engineering, Multimedia Presentation and Professional Engagement. So the professor name is Dr. Suresh Govindaswamy, and let's talk about the agenda first. So the agenda for today is Introduction to Software Engineering, enduring relevance of software engineering, historical context, solving large scale software problems, difference between software engineering and software programming, highlighting teamwork, scalability, and lifecycle management, and how companies structure teams differently for engineering and coding tasks. So, what is engineering? So engineering is the process of applying scientific principles and methods of developing useful systems and machines that facilitate and ease human life. Okay, so the examples include electronics engineering, civil engineering, software engineering, electrical engineering, etc. Okay, so what exactly is software engineering? So as we know, in today's modern world, software engineering is the invisible force powering every aspect of our daily lives. From the apps we use to order our favorite food to the emails we check, from the social media applications we use to connect to different people in the world, um, there involves software engineering. Okay, so it has now become an inseparable part of human life. So software engineering is the process of multi-person construction of multi-person software. It is a process of um, planning software features, designing, development, testing, and deployment of software systems. Okay, so the key processes include planning, design, development, testing, and deployment. And the main objective is to provide quality software delivered on time and within the allocated budget to the end users. So let's talk about the enduring relevance of software engineering. Software engineering has become an inseparable part of human life. In our day-to-day activities, we use software including every field, such as in schools, hospitals, hotels, restaurants, etc. From the applications on our smartphones to the complex systems managing global infrastructure, software engineering has become the discipline that brings these innovations to life. Um, so let's go to the history. Okay, so in the late 1960s, the concept of software engineering was emerged with the introduction of computer programming. That the programming required a disciplined approach similar to that of traditional engineering. During this period, the extras, books played an important role in shaping the field. At the time, a rapid increase in software complexity and demand was shown, where projects ran over budget, beyond the schedule, and failed to meet the requirements. Software engineering began to take place at that time. Okay, so in 1968 NATO conference, so this is a pivotal moment where the term software engineering was formally introduced. It was conveyed in Garmisch, Germany. The conference brought together leading computer scientists, engineers, and industry experts to tackle the growing crisis. The term software crisis describes the difficulties of building reliable, large-scale, and maintainable software within the budget to the requirements and meeting the deadline. Okay, so during that time, though hardwares were advancing rapidly, software development was lagging behind because of poor project management, lack of methodologies, and late deliveries of software. Okay, so in the 1970 to 1980s, in the 1970s, as systems grew more complex, development projects were delayed, cost increased, and there was unreliable software. The need for a disciplined approach to managing software development. Thus, structured programming emerged as a solution to the crisis, which emphasized a clear and modular code, reduced complexity, and improved maintainability. By applying such practices, structured programming laid the foundation for robust and reliable software systems. During this interval, Formalization of methodologies such as waterfall, structured programming, and design patterns began to rise. Object-oriented programming, which is a very important concept, by the way, emerged, which introduced concepts like classes and objects, which revolutionized software development. So the modern era, despite the advancements, many projects still struggle to deliver software within budget and on time. The traditional waterfall, which followed a sequential approach, proved inflexible and prone to failure. Therefore, agile methodologies emerged as an alternative, which emphasized flexibility, collaboration, and iterative development. The popular frameworks of agile are Scrum, Kanban, and Extreme Programming. Okay, along with this, DevOps, cloud computing, AI-driven development emerged, which made software development more reliable, cost-effective, and timely delivery. Okay, so solving modern large-scale software problems. Okay, so what are the problems that can be solved using software engineering? So let's talk about scalability and performance. Modern techniques involve designing and development of systems that can manage massive user bases and data without degradation. They are developed in such a way that they can handle large volumes of data efficiently, which enables fast data processing and data retrieving for smooth user experience. So next one is security and reliability. Software development involves building secure applications that protect sensitive user data and operate without failure. It ensures data is protected and preserved from malicious attack. Complexity management. The software is designed in such a way that it breaks down complex systems into manageable components for efficient development. This will help with the smooth maintenance of the software in the future. And last one is rapid evolution. Instead of a rigid architecture and unchanged blueprint, today's system model is designed to change over time according to the requirements. Most systems follow agile methodology where systems are built in sprints. So a sprint is basically a short time period of about 1 to 4 weeks long, mostly 2 weeks, where the development team works to complete a specific set of tasks. So this enables feasibility to changing requirements, quick iterations, and adaptations, which help change business requirements without slowing development time. Okay, let's talk about the difference between software engineering and software programming. Okay, so while software engineering and software programming are used interchangeably, both represent different approaches for creating software systems. Okay, so you can hire a candidate who calls themselves a software engineer, but your open programmer role, but for your open programmer role, as long as the responsibilities and job requirements are crystal clear. Okay, so however, understanding these two differences is very important for organizing effective software development teams. So software engineers and programmers, they are different. Okay, so how are they different? We'll talk about that. So in terms of education, software engineer has formal training and processes, and he or she should have at least a bachelor's degree in computer science or information technology. um, and however, pursuing a master's degree can be very beneficial. It may help them get higher paying jobs. And for programmer, who has a bachelor's degree in computer science, it's good, but some will hire an individual with an associate's degree as well. So let's talk about the responsibilities. Okay, so software engineer, he or she is responsible for examining client and company requirements along with the user needs to build a system that meets the necessary requirements. Their work is to test and maintain the system, often passing along individual tasks to developers so that they can spend time visualizing the system's overall construction. So the responsibility of a programmer is to code the software engineer's instructions and are responsible for identifying and fixing bugs in the software. They are responsible for fixing issues discovered during testing, document maintenance, and training and users. Okay. So role in the software development life cycle. Okay. So software engineer and programmer has different roles in the software development life cycle. So software engineer is responsible for the whole development life cycle of a software, involving from initial to the maintenance part. So a software programmer is required in only in the stage of the development in only in the development stage. Okay. So development approach. Software engineer to solve problems. A software engineer uses engineering best practices and the scientific method. And while the programmer they develop one component at a time. Considered individual programs consider individual programs. They consider individual programs and are concerned with one's functionality and visual appearance. So in the skills also, a software engineer possesses a strong background in programming and also has knowledge of advanced mathematics. Some of the skills involve programming proficiency, problem solving, data structures and algorithms, software development methodologies, version testing, database management, etc. While the programmer should be efficient in programming languages such as Python, C++, Java, etc. So work dynamics. Okay, so software engineer usually collaborates with other engineers in a team, while a programmer usually works alone. They are guided by software engineers. Uh, okay, so teamwork in software engineering. Let's discuss about the teamwork. So cross-functional collaboration. Software engineers closely work together with the product managers, designers, testers, and stakeholders to align technical solutions with defined business goals. Code reviews and standards. Um, Software engineering teams establishes protocols for the team for code quality, code documentation, and knowledge sharing to maintain consistency across the team. Okay, they maintain a standard and proper documentation so that uh, code maintenance can be done easily and would be easy for them to train new software developers in the future. System integration. They coordinate how the various components and services work together to make sure seamless integration across team contributions. Okay, so scalability engineering for growth. So current scale, while designing systems, the software development team builds systems which can manage current user load while anticipating future growth patterns. Horizontal scaling, the team creates architecture which can add more servers, services or databases as demand increases. Okay, for instance, with the increase in demand for a particular software, the teams ensure to build such systems which can be scaled easily. Performance optimization. So performance is a crucial part while designing software to enhance user experience. The software should be fast, thus they build monitoring and optimization techniques to maintain speed and reliability. So here the main goal of software engineering is to make code work. Software engineering guarantees that it will continue to function for millions of users for many years to come. Okay, so software development life cycle. So there are um, processes while developing a software, and some of the processes include so for example the first process is requirements and planning. So in the requirements phase, they gather information from the stakeholders, from the end users. So they plan for the system. Okay, and design and architecture. So in this phase, the team creates system blueprints, chooses which technology to use to build the system, um, which programming language to use, and establishes patterns for maintainable code. So implementation, this is another critical phase in the software development lifecycle, because here actual development starts, where the team codes, reviews, um, and builds the system. Testing. So after implementation, there the testing phase comes in. So after development, The testers perform automation or manual testing of the software to ensure the code is bug-free and the system is working as expected. So the next phase is development. So deployment. So after developing and testing the software is ready for the deployment phase. So the deployment means making software available to the end users. So maintenance and evolution. So after deployment, uh, the users may find certain things, certain bugs, or certain features to be updated. So these things are done in the maintenance phase, and in the maintenance phase. And if there need to be some object updates, so these things are done in this phase. So so the last part is how companies organize teams differently. So software engineering. So in software engineering, the teams are structured around architectural decision making and product ownership. There are technical leads and architects who play a crucial role in guiding software development teams. By combining technical expertise with leader responsibilities, the teams make sure they collaborate with the testers, developers, and stakeholders and maintain system-wide oversight to guarantee that all components work together smoothly. Okay. So they not only focus on daily problem and solving, but also on long-term strategic planning, shaping the technical solution and ensuring scalability and performance. Software programming. Okay, so junior and senior developers and other programming focused positions are mostly concerned with creating features and producing code for designated tasks. These positions place a strong emphasis on individual contribution, with developers using their technical expertise to fulfill urgent objectives and shorter project project schedules. Their work is typically scoped to specific tasks or features, as opposed to more system-wide duties, guaranteeing that deliveries are finished effectively. In order to facilitate swift development and modification to project requirements, teams in these positions are usually structured around immediate outputs and the specialized technical knowledge needed. Okay, so if you have any questions, you can ask me. Okay, so and thank you for listening.